We're going to continue with our lesson on writing linear equations in standard form. The end of our last video, we were talking about, given a point -4, 10, what's our equation of the vertical line? And we were discussing that a vertical line is going to go up and down. So we gave ourselves a little sketch of -4, 10. We put it kind of up here. And we were trying to come up with the equation. Now, if it's crossing the x-axis, our equation will be an x equals 2. And we use our ordered pair to figure out, well, what is that x going to be equal to? And my ordered pair says -4 for x, so that's my equation. If my equation is a horizontal line, that means it's going side to side. Across, it will go across the y-axis, so my equation will need to be a y equals equation. And again, I look at my ordered pair to see where is it crossing. It's crossing up here at 10, so that's my equation. We're going to continue with our lesson and move into parallel and perpendicular lines. We already know that parallel lines have the same slope. Therefore, two linear equations that have the same slope must be parallel. We're going to go ahead and write an equation of a line that passes through the point -3, -5 and is parallel to the line y equals 3x minus 1. Well, if we know our line is parallel, then we need to have the same slope. If we have the same slope, then our lines will be parallel. So we're going to go ahead and write an equation using the exact slope that was given to us. So when I look at my equation, my slope is right here. So my slope is going to be 3. And then I take a page from my previous lesson and use that slope and the point they gave me and go ahead and write it in point slope formula. Remember, point slope formula looks like y minus y1 equals your slope times x minus x1. The y1 and the x1 come from your ordered pair. So we're going to say y minus -5 equals our slope times x minus -3. Before we distribute, we clean up those double negatives. So we'll have y plus 5, x plus 3, and then we distribute. Last, we're going to subtract 5 on both sides. And we'll get 3x plus 4. Now, we want to make sure we read our directions carefully. If it just says write the equation of the line, then you're going to want it in what we have here, slope-intercept form. If it said put it in standard form, then that would be an extra step. And you can watch our previous video on how to change this equation into standard form. But we're good with right here. Write the equation, that's what I want to see. Same slope and a different y-intercept. Now, perpendicular lines are a little bit different. And my two graphs kind of show that. If I have one equation with a slope of -3, 2 graphed, and if I want it perpendicular, I have to rotate that whole line 90 degrees in either direction, clockwise. We'll show that here in the second graph. If we do that, then the slope of the line has changed, and it's changed as a rise of 2 and a run of 3. Perpendicular lines have slopes that are negative reciprocals. What that means is if we take this slope and just multiply it by -1, number one, we're going to change the sign, but we also have to take its reciprocal. What is a negative reciprocal? So a negative reciprocal is, again, when we flip our fraction upside down and then change it to its opposite sign. So if we had a slope of 6 and we wanted to find its negative reciprocal, first I'd change it and make it a fraction. Then I'd flip it upside down and then multiply it by -1 and we'll get our negative reciprocal. You try it. What if you had the fraction 5/4? First you flip it, and then you'll multiply it by -1, and we'll get -4/5. These are negative reciprocals. They will give you the perpendicular lines that we're looking for. Or not, yeah, perpendicular. Negative reciprocal slopes. So it says determine whether any of the lines are parallel or perpendicular. Okay, well, in order to figure it out, I need to figure out what their slopes are. The slopes tell me. If they're parallel, they're going to be the same. And if they're perpendicular, they're going to be the negative reciprocal. So let's see. For the first one, my slope is given to me. It's 5. All right, let's take a look at the second one. Well, it's not in slope-intercept form, so I can't right away the slope. So I'm going to put it in y equals form, which means I'm going to subtract x on both sides. And then I'm going to divide by 5 everywhere. And I'll get y equals -1/5 x plus 2/5. And in this case, we don't really care what the intercept is to determine slope or perpendicular, or parallel or perpendicular, because we're really looking for the slope. So here's the slope there. And then we'll look at our third line. I'm going to go ahead and add 2x to both sides. And then I'm going to divide by -10 everywhere. And simplify. And take a look at my slope here. So now that we have our slopes, what can we conclude? Well, let's see, which slopes are the same? Line B and C. So we can say line B and C are parallel. They have the same slope and different y-intercepts. And what do we know about the slope of A? It's not the same, but is it the negative reciprocal of -5? The answer to that is yes. So we can say that line A is perpendicular to both line B and C. I'm just looking at their slopes and seeing if they match. If they're the same, then they could be parallel. If they're negative reciprocal, then they're perpendicular. Write an equation of the line that passes through 4, -5, and is perpendicular. Okay. First thing we need to figure out is the slope of our original line. The original slope is 2. I'm going to write it as a fraction, because if I want the slope of the perpendicular line, I have to take its negative reciprocal, which means I have to flip it and multiply it by -1. So when I flip it, it becomes 2. When you flip it, it becomes 1/2. And then when you multiply by -1, you get -1/2. So that's our slope that we're going to use to write the perpendicular line. Now we need it to go through 0.45 for -5. So we're going to use our point slope formula. So we're going to say y minus y1 equals, use your new slope, x minus x1. Clean up those double negatives over here, and we'll distribute. and subtract 5 on both sides, and we'll get y equals negative 1/2 x. If we subtract 5, we get minus 3. All right, you've got a chance to take a look at 4 different problems. And these problems not only ask you to write the equation, but they specify, write it in standard form. So I'll just remind you that standard form is when it's ax plus by equals c, and we want it in the best standard form. And that's taken care of in our previous video, but standard form, we want to make sure our coefficients are positive. That first coefficient is positive, that our coefficients are not fractions, and that there's no common factor between the two coefficients other than 1. Go ahead and pause the video and take a look and practice, and then check back in for answers. Okay, we'll take a look at our answers. If we're writing equations in parallel standard form, you need the same slope. So if we take a look at A, our slope is negative 2. We put that into point slope, and then we're very mindful of those double negatives. We went ahead and completed that point slope, and we got y equals negative 2x plus 0. That's slope-intercept form. Moving it to standard form, we just add 2x to both sides. We get 2x plus y equals 0. Letter B, same process, but our equation needed to be in y equals form, so that's what you see here. So therefore, our slope is 3. So we use our slope of 3, and we be very mindful again of cleaning up our double negatives, and we'll get an equation of y equals 3x minus 14. Now to put it in standard form, we subtract 3x, and now we have negative 3x plus y equals negative 14. That's in standard form, but it's not the best. So we go ahead and multiply by negative 1, and that will change it all to 3x minus y equals positive 14. For perpendicular, we have to remember we take the slope and use its negative reciprocal. So our first slope for C is negative 1/2. The negative reciprocal is 2. Go ahead and use 2 as your slope and your point in point slope formula. Clean up double negatives. You'll get y equals 2x minus 3. And now we need to put it in standard form, so we subtract 2x on both sides. This is okay, negative 2x plus y equals negative 3, but it's not in the best standard form. So to get full credit, we would multiply by negative 1, and we'll get 2x minus y equals 3. For letter D, again, this is not in the right form, so we need to change it into y equals first to find our original slope of negative 5. If our original slope is negative 5, then its reciprocal is 1/5. We plug that into point slope, clean up double negatives, and we'll get y equals 1/5 x minus 3. To put it in standard form, we subtract 1/5 x. We get negative 1/5 x plus y equals negative 3. Now we have a negative leading coefficient, and it's a fraction. So I chose to clean up both of those things. So I'm going to multiply by a negative so that I no longer have a negative coefficient for x. I'm also going to multiply by the denominator of 5, and that will clean up the fraction. So negative 1/5 times negative 5 is going to be a positive 1. And then you have 1x minus 5y. And let's see. I've got negative 3 times negative 5. Does that look right? I think we need to change that last one. I think it's a positive 15 rather than a negative 15. What do you think? Negative times a negative is a positive. And that's how we go ahead and write equations that are parallel or perpendicular in both slope-intercept form but also standard form. Let's review. Parallel lines have the same slope. Perpendicular lines have slopes that are negative reciprocals. To determine whether lines are parallel or perpendicular, find their slopes. If the slopes are equal, then we have parallel lines. If the slopes are negative reciprocals, then we have perpendicular lines. You find your slope by always putting it into slope-intercept form. Find a line parallel or perpendicular to another that passes through a given point. We need to either use the same slope for parallel or the negative reciprocal for perpendicular, put it into point slope formula, and then solve.